So what might be a good? So we can't jump right into this. There's lots going on, and so we talked about sub goals, right? Sub goals. So what might be a nice, easy thing to start with? It will just help us get started towards. What's that? Okay, making the triangle. So hopefully that shouldn't be too bad.
Making a center.
What's that?
The next one I'd say is probably making a center of a circle to start rotate, to see it rotate around, and then work on making it a slider rotation.
Okay. Rochelle.
I guess I would probably take a step back from maybe both of those and try and get something to rotate about a center and just getting this rotation.
Okay, so what would the easiest case of that be? We want to get something to rotate. What would the easiest case of getting something to rotate? A point about
The origin.
the origin, right? So let's see if we can rotate a point about the origin. Okay, so here's what this is. So actually, the starting point is changeable. So right now I've got it starting at 3, 1. And as I change the angle, then it will rotate, starting whatever that point is, about the origin at the right radius. So let's see if we can accomplish this, which is is a smaller task than the first one, but it's still a significant task, okay? It's still a significant task to get this done. Okay, so the way we want to approach this, we've got to kind of derive some relationships here.
Random question: if you don't give a slider a number of steps, what is the default it uses?
I'm not sure. 100
That's a
or
lot.
something? Maybe 50 or 100? I don't know.
Like choose some arbitrary.
You'd have to mess around a bit, figure it out. I don't know off the top of my head. Okay, so everyone see what the goal is? So let's kind of illustrate the situation. Here's the setup, right? So the point x1, y1 is our point A. Okay? And then the A then would be the angle. And then x2, y2 would be the final point. So what does this have to do with functions? What does the principle of functions have to do with this? What is a function? Relationship input and output. Okay, so what might we think of as input and output in this situation?
The coordinates would be our input, and where it gets rotated to, the coordinates of its end position is
Okay, so what I heard you say, I think what I heard you say was that x1, y1 is the input,
yeah.
and x2, y2 would be the output.
Yeah.
Oh, man, it doesn't like that.
I'd say your angle, your slider.
Angle is which?
Is your input.
Is your input.
I think it's both.
Both. So is it the point x1, y1? Is the angle A, or is it both?
In this situation, it could just be the angle because our point is set,
I think
and you could incorporate that into your function. It's fine.
Okay.
Angles would be more like our standard and where the angle will increment and I'll rotate around.
Okay, so I'm changing the angle, right? Maybe. I'm changing the angle. But I could come over here and I could change this. So now my starting point is -2, -5.
Is there a way to call one part of the point?
Say it again?
Is there a way to, like, if I wanted to call the -2 using A, is there a way to do that with this?
Um,
Like A1 or something?
No, the real question is there a way to call a whole point? I mean, that's what you want to do, right?
Yeah.
Yeah.
This is just about how to graph that point, but when we're graphing like a equals and then the point, it's not graphing for us.
But if you don't
Point, but if
put
you
it,
just do the point without the a equals, then it would.
It's the same thing as defining a function versus graphing a function, right? If you define a function, it doesn't graph it.
you have to call it.
So you have to say.
And
Oh, do you understand that?
we're reading
Okay, so we're having a discussion about input and output. So what's the input? So the input is it this point? Is it the angle or both?
oh, I'd say the point is a predefined constant.
Okay.
Because I mean, yes, you can change it. But I mean, you can change any constant if you want to in a function. If I have
So when we define our relationship that's going to output this point, does it require just the angle to be the endpoint? Does it require this point to be the input, or both to get a final value of that point?
I guess it's equal.
It's got to be both, right? It's got to be both. So this can be that's a function of two entities. A function of two entities: the angle and the starting point. And then the output is this point x2, y2. Okay? So we need to build up the mathematics to do this. Okay, this is not a quick and easy thing. So I see people typing and trying to do it. So without the mathematics behind this, I just oh I see. I wanted a new one of these. Okay, the wrong new. Okay, so. So how are we going to start here? So we've got this point, x1, y1, and this point A. How can we get going? We've got to develop some mathematics so that we can write x2, y2 as a function of these two things. What are some things that are going to be involved here? Circles.
Sine and cosine.
Sine and cosine. Need some trig to do this? Okay, so let's see, can we define the coordinates of this point? So how would you define the coordinates of this point right here?
R times cosine of the angle.
What's that?
R times the radius of the circle.
Okay, so we got a radius here. So x1 you're saying is?
X1 is R times the cosine of the angle.
What angle? Angle A?
No. Angle between the x-axis and
Oh, so a different angle.
Right.
cosine of the tangent of y1 over x1.
So can we just call that, let's just call that B. It's a different angle, right? So that starting point has an angle. So x1 is R cosine B. And y1 is? R sine of B. Okay, what about x2 and y2? So x2, somebody new. Steve, can you write out what x2 would be?
Would be x2 equals r cosine of a plus b.
He wants r cosine of a plus b. All right, keep going.
And then y2 would be r sine of a plus b.
What do you think? Okay, now what? So this is a good start because x2 and y2, those are going to be our output, right? So we've defined x2 and y2 in terms of r, a, and b. So what did we want our inputs to be?
X1, Y1.
Right, x1, y1, and a. Okay, so we got some work to do, right? So right now it's in terms of r, which is not defined, or not defined once x1 and y1 are defined, but it wasn't part of our input package, right? And neither is b. So what can we do? Any ideas? Steve?
Can we solve x1 and y1 for b?
Solve x1, y1 for b.
You also need to find r in terms of x1 and y1.
Okay, find r in terms of x1 and y1. Okay, so that then if you're solving for b, then we're getting inverse cosine, inverse sine, which can kind of get a little messy, a little problematic. Not a bad idea though. Yeah.
Or we just move our points so thus we don't have to handle the p. We can move our x1 and y1 to the x-axis.
No, but we're allowed to start that x1, y anywhere, right? That's that point A.
Can you find the distance from the origin to the point?
Okay, so that we get rid of r. Okay, which would be just like distance formula. Okay, all good ideas. What we want to do is look in the back of the book for what? Trig identity. What is cosine A plus B? Anybody remember?
Wasn't it like sine? It was like cosine A.
Someone look it up online. What is it? Is that cosine A, cosine B minus sine A, sine B? Is it
Something like that.
something like that, right? Exactly.
Cosine A times cosine B.
Cosine A times cosine B minus, is that right? That was my guess. Is it right?
Come on, Mark, let's get it memorized.
I'm anti-memorization when it comes to learning mathematics. Is it right?
Yeah.
I
Sweet.
didn't see if the rework out the triangle.
All right, so x1.
Takes so long.
I think that x1 is sine A cosine B plus cosine A sine B. Is that right? For sine A plus B? Sine A cosine B plus sine B cosine A. Ha! I got them both.
It's supposed to be y2, right? Not x1.
Yeah, thank you. Someone's paying attention.
Rotation matrix.
Do I get them right now? Okay.
Yes.
So what was our goal? We got to get rid of B. Any ideas for getting rid of B?
Now you could do a sine inverse on the y1 and now we get rid of it.
Yeah, we talked about that before. We want to avoid inverse because that can get a little ugly. Because our angle gets restricted, right? With inverse, the
You're with car.
yeah. Anybody see anything? You see it?
Yeah, well, x1 is that r times cosine.
Right.
of b, so you can divide, it'd be x1 over r.
Or we could can't we just get x1 in here?
Yeah.
Yeah.
So
X1 is?
R cosine.
So there, when we multiply r in here, there will be x1, right? And then when we multiply r into here, we'll have? What will we get when we multiply r times this?
Y1.
We can get y1, right? Okay, so x2 is cosine A times x1. minus
y1 cosine
y1
of sine.
sine A, right? Look at that. So now we got our desired inputs, right? And y2. Apply the same thing.
y1 sine
y1 sine A
plus x1 cosine
x1 cosine A. Look at that. Okay, so we got it. We got x2 as a function of x1, y1, and a, and we got y2 as a function of x1, y1, and a. But what we can do now is we can group these together as a single entity. We can see that out that point. We want to put that together as a point. That's a single entity, and same with our x1, y1. Okay, so this brings us to matrices. Do you remember how to multiply matrices?
Yes.
Do you see how this can be the result of a matrix multiplication? So can you write what two matrices multiplied together would result in the matrix x2, y2? Can you do it? If you remember how to multiply matrices.
I have it.
So remember, you go in your first matrix, you go across the row while you go down the column, and you multiply and add. So you go across the row, and you go down the column, and you multiply and add. So it's going to be something times x1 plus something times y1. Going across the first row, what will it be? What do we need times x1? Cosine A.
Cosine A, then sine A. On the
Sine
bottom.
A.
Negative sine A there.
No, but see, you go across the first, in the matrix, you go across the row while you go down the column, and that's how you form. So yeah, so it'll be negative.
Sine
And then?
A.
And we're going across this row, and again, down this column, and multiplying and adding. Is that familiar?
The rotation matrix.
Right, exactly. It's the rotation matrix. So what do we got? This is A. And what do we call this?
I call it B.
What do you call it? What?
I call it B.
B. What is it typically called?
Rotation matrix. I
Mm.
don't know
It's
what
just,
similar.
I think it's R or something like that. Maybe R.
Yeah, but R is going to be the name of our function. L, have you
Linear transfer.
linear transfer? L.
Just use the math.
Okay.
Just show that. It's like
Let me just check.
R
I want to use what we use. Here.
Oh, they call it R theta.
you made this function R.
Oh,
So don't be on board. See.
We don't need a name for it. Oh, did I erase everything?
Oh,
We can't
check this off.
No, but I think I erased everything we wrote. Dang it. How did that happen? Bummer. Yep, it's gone. All right. So anyway, we got. What was our final result? Was that x2, y2? Yeah, it's all recorded. All right. Cosine A negative sine A, sine A, cosine A. Okay, and so this is, that's our A, so we'll call it X. Okay, so our starting point is capital X, yeah?
I was wondering if we multiplied the second row with a first column,
Uh-huh.
wouldn't we get x1 sine A
Uh-huh.
and then y1 plus y1 cosine A?
That's right, is that what we got for Y2?
I thought y2 was y1 sine A.
Yeah, it is.
Oh, then we got the wrong. So, are you saying this should be cosine A sine A?
Yeah.
Yeah.
I don't think so.
No, it's cosine.
Because you take
On
your
top.
first
Yeah.
row and you multiply that by your column.
What did we get for Y2? Y2, what did we get?
X1 sine A.
Sine.
Was it x1 sine A?
Yeah.
Yeah, it should
Pl-
be cosine.
Plus,
Yeah, it should be
So-
No, it's y2 is y1 sine A plus x1 cos.
what did we get?
y1 sine A
plus
plus
x1 cosine
We had it
So they're
switched,
added,
so we can switch it for
That's what I have written down.
So this is cosine A,
That should be sine.
and this should be sine A? Did we do this? Did we get this the
I think we got
identities wrong?
Yeah.
Yeah.
You guys.
Yeah,
Yeah,
because
this
it
is
should
not
come
right.
out- It should come out with sine and then cosine.
Y2 was R sine A plus B. All right, what's the identity for sine A plus B?
Sine A cosine B
Sine A cosine B?
plus sine B cosine A.
Oh, we did have it right.
We did have
Unless
it
this website's wrong.
I doubt it.
No, I haven't did one.
Therefore, x1,
Sine
so this is x1 sine A, right?
Yeah, but we had it written
We had-
Y1.
yeah. So we just did that wrong
Yeah, we wrote it.
when we first did it.
And then this is,
Multiply the matrices.
Y cosine.
okay, phew. Now are we straight? So was this written incorrectly?
Yeah.
So we had the identity right, but then the mistake was from there to there.
Yeah.
Okay, cool. So now we got the right. Are we all on the same page? Are we good?
Yeah.
Okay, cool. Sorry about that. Okay, so
Do 8 times.
so we can write this as a function. This is our output, which we're going to call the function r. And that function r is going to be a function of a.
Oh wait, do b times a. We are the when you multiply matrices. When you multiply matrices,
It has to be a. This has to be the same.
the two.
So now we want to define this function, a function of the angle and the starting point. Okay, so we're ready. I think we're ready to see if you can do it. So now, we call that point A, and then we're going to find this function as taking the starting point called x and the angle A. Okay, so these are just placeholders. These are just local variables that are just going to be part of this rule. But then when we actually invoke R, we can use different symbols, right? So like when we invoke R, what's going to be there? What was our slider called?
Angle.
Angle, right? So these are just local variables that define the rule, so that anytime you invoke and call upon R, whatever you put there, it's going to substitute into the rule wherever there's an A. Okay? So see if you can finish the little rotation. Anyone got it going yet? Got it?
Yeah.
Use the function though. use a function. Set up the function and use the function to do it.
Alright.
Okay.
That's a requirement. If there's anything I want to get you guys in this semester is to start developing a functions mentality about ways of developing things. Like in the step from left, did you find yourself typing the same expression in over and over and over again? If you did, we haven't gotten to a functions mentality. You define that function, then you use it every time, right? That's what a function does. It
Instead of
allows you to repeat a process.
Instead of A, can we just put angle? Because that's what I named my slider.
And I named my point A, so. I mean, we could rename it, it's not hard.
No, use local variables a and x, and then when you call upon the function, then use angle.
Okay.
You see? Use local variables a and x in your function rule, and then when you call upon it to find that point r, then you can plug other things in. Yeah.
How do you build a 2x2?
Oh, anyway, how do you do
Control shift.
Control shift 2.
Can you put that?
So are we supposed to set our function equal to the major function?
So you don't want to get rid of that.
You don't have
I just want to say there's a note, just so I remember it.
Okay. So now what's the function? What is define a function just like that. R little a comma x. Those are the local variables in your definition. And then is it good?
There you
They have a matrix.
Oh, what's going on? Oh, I see. This is the function definition, right? This is what you want the way it is. Use capital X. And then when you invoke the function, yeah, you still want that to be
What
A.
is A?
Here you just, all you're doing is
just
defining the
rename
function.
A.
You're not using
No,
it, not
you define it.
using it, you're just defining it.
You are angle comma A.
Oh, okay. Should we do capital X?
We're creating the program now. We've got all the tools and so we're now creating the program.
Oh, okay. Well, we call it capital.
Any questions?
Mark, what are we, I'm confused, what are we calling, because we know that last matrix, the one that, the 2 by 1 or whatever it's called.
Yeah.
Is, we're gonna call it X, or its name is X,
Okay.
but how are we defining it in our command line? Are we literally like,
In the definition here?
yeah, because we should have two matrices being multiplied
Right.
together as our definition.
Right.
Are we leaving it as,
Well, this says
Oh, okay.
if this is X, and that's what we're calling the local variable,
then we're just multiplying by
Okay.
capital X?
by capital X.
Okay,
Yeah, you have to use the variable.
and then we'll define capital X later.
No, but so then when you call upon the function, whatever you put there when you call to use the function, it's going to substitute it there. You see?
Yeah.
So we're gonna plug in a point.
So we're gonna be
So
plugging
you
in a
define
point.
function f of x. and then
Yes, that's what I'm saying. This is a point. This is an ordered pair. Exactly. So
So we'll be doing like R of, I don't know, pi halves and then point B, where we define B later.
oh, so what will that be? You know what that's supposed to be, right?
So let's see, it's
Yeah, actually,
one radius. Our point is
Capital A.
1.
When you use the function, then your starting point is what the user defines as capital A.
Oh.
Ah.
Alright.
Yeah, so yeah, we got it.
And then capital A.
So we have to X.
Anybody?
You don't want to do specific angles and points here. You want to be able to change your slider and change your A.
Oh yeah, I can just put it as a slider.
Well, what did you name your slider? Because that's your angle, right?
Yeah, the where I put the one.
Okay, that looks good.
So put your whole angle.
Yeah, but I can just rename the angle to A.
Right, but you call it one down.
No,
This is your
these are the
Wherever you put
inputs.
here now, it's going to go up to the definition.
But you
It's
put
going to go there. You want to put that there.
What do you want to do?
Yeah,
So that way, when you change your point up here at the top, or you change your angle slider.
So should X be capital A?
Yeah. So in my
Where would you name your slider?
That angle.
Replace one with two. And then when you change stuff at the top,
Oh,
that should be
I see what you're saying. Okay, that makes sense.
now.
Here are the first three lines.
Change the sliders.
Oh.
Here are the first three lines. The angle slider, the starting point, we were calling A, and then this will just graph that point A. It's stationary, so when you start rotating, it'll stay there.
We want that. Okay, we want it to stay.
Those are the first three lines. When you define the function, use little a and x as the local variables in that line for defining the.
So
Yeah.
What is this output? What will that give you as an output?
This should be.
No, because when you use it, you just got to make sure that
Because
you
what
use
is
it.
X?
There is
What is X
that
gonna
kind
be?
of thing that you put there. Then it'll line the rule until it's multiply it by that. So no, you don't need that.
The X together and the Y together.
Right.
You don't need to do that.
Yeah.
So when you multiply this,
Well,
you should get this and that.
Yeah.
See, this you're defining it, and now when you use it, what do you want A to be? What
So this is going to go. So what are you going to do here? You don't need this stuff. You're just going to call it.
So when you use the function, what do you want to go there, and there? That's what you're going to put there. See, because the rule says whatever's in that first spot means the cosine of it, the sine of it.
Because this gives you.
So now we use this function. What do you want? Right.
I got to do all the stuff.
What's going on?
That's good.
So make sure you understand why it works. Okay. This is really about understanding functions.
You could do that, or you could just call. Think about it this way. You could call your function
That's
on.
what you're gonna
Like, you just find it here.
Yeah.
You find it here. Just call it with angle and A as your inputs. Just like if you
say call.
because you
Who
define
needs
your
help?
function, you want
Anybody
call.
need help?
Okay, so I'll just do
This,
R.
you could see it.
Okay.
I don't think we would have.
So we're on time at X. I can't graph equations of this.
Make sure you're multiplying your matrices in the right matrices in the right order. Because remember,
Okay, so what I want you to do is tell the person, take turns, tell the person next to you. Is this what, so, right here, this command line right here. Explain, when you write that in your graphing calculator, what does graphing calculator do? How does it interpret that line right there? So take turns explaining that to each other. What does graphing calculator do with that right there? Go.
yeah, there you go. Yeah. There you go.
Wait, if you do that.
Can you?
Oh yeah.
Just.
Oh, I put A as my angle. That's why.
Yeah.
I was looking at that.
You just reverse the order you put your inputs in your function definition. That doesn't change anything. It's put them in the right order when you call them.
We had like a.
So So I mean, if it calls this point A, which goes first to the next point, and A.
Yeah, but we kind of like, you know how you have to do wow, because if it's like a functions. We did it as like a new special. But you can just type it. Yeah, well, it's just assumes. Yeah.
Okay, who wants to try? What does graphing calculator do with that? What happens? Why does this work?
Nothing. Wait.
Yeah, what does that?
Bennett, want to give it a shot?
Yeah, it just substitutes in for the above function. Well, yeah, there you define your function for specific values of a and angle, but it's just taking those and using the same function of Rx of NA, and it's taking a and placing it where x is.
Okay, so it looks at this and it comes to here. It does what? It takes the A and does what?
It puts it where the x is in the above function.
Here's the rule. So it says,
There's
okay,
the rule.
anything that's in that first slot, what's graphing calculator going to do? It's going to put it
Right where the x is.
there. Okay, so it's going to say, okay, I'm going to put A there. And what is A? A is that point, whatever point we chose. And then what?
And then it's going to take the angle.
It's going to take the angle, that's the current value of the slider.
And it's going to put it in for where all the a's in the rule above.
Everywhere there's a little a, it's going to put the angle in. And then it's going to evaluate that product, and what's it going to get?
The rotation.
Yeah, so you'll get, when you multiply this 2 by 2 by this 2 by 1, it'll give you another 2 by 1, which would be the point. Okay, so again, these are placeholders. It's what's called a local variable, meaning it's just the dummy variables that it's using in that rule. It's just a place. So whenever you call on function r, whatever goes there, it's going to plug in wherever there's a capital X in the rule. And similarly, whenever you call on r, whatever you put in the second slot, it's going to replace every little a with that, and then it's going to evaluate that, and that's the output. Okay, so moving the next step towards our triangle double rotation, what might we do next? Next level of difficulty, or move the center. Oh, do I have that one open? Where's that? Oh, here it is. That's it. Okay, so a starting point. Is this working? Yeah. I've got it as gray. Can you see it on there?
Yeah.
The gray initial point. I'll make it red. That should show up as something. Okay, so now my center is at 4, 1. My starting point is at 2, 5. And if I move the angle, it will rotate about a different center. So in accomplishing this task, what will be the overall goal to accomplish this task? What will be your goal? Okay, I know Grant knows. Anybody else? As you're creating this program, there's kind of one centerpiece that you're trying to achieve. And if you can get that, the whole thing will fall into place. What is this one thing you're trying to get? What's that?
I did a rotate a point right into that point.
Okay, well that's what we're doing. But so in the creation of getting one point to rotate another point. What's that?
Moving your point from the origin.
Moving the origin.
Wouldn't you want to kind of start in a similar fashion to how we started with the origin, trying to reconstruct this idea of how to define
Okay, so that would be a way to start. But what is the goal? What's the centerpiece? What's this thing that we need that will make this easy and possible?
A function.
A function. Yes, a function. What function? So we'll call this one R. And what will, if
This function will take, well, it's going to take similarly, right? It's going to take A and an angle.
is it gonna take an angle?
Yes.
Okay. Was that the first thing? What did we have first?
On the other one, you had your point first and then your.
Okay, so will it take the starting point?
Yes.
Okay. What else will we need? What else will the input of this function be?
The center.
We'll have right? That'll be a function of the center. And what else? The angle, right? Creating this program is about creating that function. Once you get that function, it's just the syntax, right? Just that thing we worked on. Getting the symbols in the right place. But the whole ball of wax here is making that function. What is the rule that involves your initial point, your center point, and the angle? What's that rule going to be? So that when you define those three things, change the angle slider, it'll move around. So that's the task for Monday. That's what you're doing for Monday.
So we're just trying to find a function.
No, you're going to build the program. You're going to build the file. But what I'm saying is 98% of building that file is getting this function. Once you get that function, then it's just a matter of getting your symbols in the right place, the syntax right. So the work that you do to get this to work is designing that function. Yeah.
Can you move your slider again?
Sure. So all this is the only difference here is now instead of the center being the origin, the center is also at a chosen point.
That's the
Any questions? Okay, so I've been late several days, so let's be early today. So a recap. Sunday I'll send out an email. You're going to respond with 2 files, step from left, and this. And then Wednesday is the lesson logic reflection, based on what I did Monday.
Lesson logic